equation of a circle in a sphere. We have considered equation of a sphere. Now, when we talk of a circle in a sphere, circle is a plane section of a sphere. If you look at this, let's assume that this is sphere. This is center of the sphere. This plane section here will become a circle. This plane section here will become a circle. So this will be the radius of the circle. Let's put it as r, and this is this place. This is center of the circle. This one is radius of the sphere. As big R. Look at this one. This one will be radius of the circle, and this is the height. So let me call it L. This is height. Let's put this is M. This is O. O is the center of the circle. Now, from the we have the following from this diagram. This is the first one. This OM, which is L, is the length of perpendicular line from this center to the sphere. From the center of the sphere to the circle, as we can see it from here. So this is the center of the circle. So this big R is the radius, and the third one, that small r, is the radius of the circle. This big R is for this sphere. Also, we know that this 0, as we said before, is the coordinate of center of the sphere. And finally, from Pythagoras theorem, we can have that this small r is equal to big R minus this L. This L can be obtained using the formula, as we know, using the formula AS1 plus. This is the formula. So this is that is the length of a point to a plane. So that plane now is what we are talking about. Now we will now want to look for the equation of a circle. In a three-dimensional analytical geometry, two equations represent a circle, and these are this and this. So we know that this one is for a sphere and this is a plane. So when we have a plane and a sphere together, then the two equations represent a circle. So this is called equation of a circle. So this is it. These two equations are called equation of a circle. Now, when we have this, if you want to find a sphere that passes through this, we know that, let's assume that let S be a sphere and let P be a plane. Then equation of a sphere through S and P is given as, it will be S plus MP equal to 0, where M is a constant. So where M is a constant. So now let's take example under this. Now I want to find the equation of a sphere that passes through this circle and also through this point. From what we said the other time, when a sphere passes through a sphere and is a plane, then we said the equation is MP. S is sphere, P is plane. So the equation, the required equation is this. And that is what we have written in this place. The next thing is we need to simplify. You need to simplify further. So this is minus 4SL. We need to write it with this one. And in doing so, we are going to have, we have this. Now, this is the required equation of the sphere. But we need to know that the sphere we are talking about also passes through this point. We need to do so in order to find the value of this M. If it passes through this point, definitely it must satisfy this point. That is, we can put S to be 3, Y to be minus 1, and Z to be 1. And in doing so, we should have the following. This will be 3 squared plus 1 squared plus 1 squared plus, this is s is 3. This will be plus 3 into minus 4 plus 3m. My y is minus 1. This will become plus 4m plus our z is 1. This is 1 into 2 minus m plus 3 plus 3m is equal to 0. So we have equation only in m. So this one is now easy to do. We can find the value of m here. By simplifying, we are going to get m is equal to minus 4 over 17. So we have found the value of our m. So we can now substitute m back to this place. So, and in doing so, we need to substitute anywhere we see m, we put it here, and we simplify. So by doing so, we are going to get this. So what we have done is we have substituted this m inside this place, and we got this. So finally, the final simplification will give us this result. Now let's consider another example. We have another important question. Obtain the coordinate of the center and radius of this circle. You know, this sphere and this plane become a circle. Now, in order to obtain, we need to draw it the way I drew it the other time, so that it will. Let's assume that this is the center of the sphere. This is the circle we are talking about. You need to draw it. Let's draw a perpendicular line here. Don't mind my drawing. This place is the center of the circle. Don't mind my drawing. This place is the radius. Let's assume that this is L, this is M, this is small radius, and this is, let's say, P. Now, our aim is to find the center, the coordinate center of this circle. Also, we want to find the radius of this circle, but we can easily find the radius first. We know that radius is radius here. We can get this one, this L. We have known how to find this one, but the radius of this circle, this sphere, is our R. This O is the center of this sphere, so we need to find it, and it's easy to find center of a sphere. You know, center of a sphere is this over 2 negative. 4 divided by 2 is 2, so we have minus 2 there. This divided by 2 is 2. We still have minus 2, and this divided by 2 is minus 3, so this one will be 3. So this is let me say this is O, center of the sphere. So let's keep that. Also, we need to find the radius of the sphere. So we know that radius of the sphere will be equal to this square plus this square plus this square minus 19. So this will just be 2 squared plus 2 squared plus 3 squared minus 19. So our 19 will just become plus 19. From that place, we can find the value of our radius, and that will give me 6. This will be 36, and square root of 36 will give me 6. Now let's keep that. So we have known the center, we have known the radius of the sphere. Now we need to know this line, this L, and we know that L is the length of this line from O to M. O is the center. This to this plane, sorry. This plane has been given here. So we need to find our L using the formula. So we use the center. So our L will be 2 into minus 2 plus 3 into minus 2 plus 6 into 3. You need to bring this 12 in. Now we have minus 12. Let me put absolute value there over square root of a square b square is this plus this and this. 2 square plus 3 square plus 6 square. So that will be our A. We have given this before, and also we gave it here too. This is what we are trying to use. So from that place, we can find our L. By the time we simplify this, we should be able to have 4 over 7. So we have known our L. From that place, we can find our R. Remember, we say that by Pythagoras theorem, R will be equal to the square root of big R squared minus L squared. So our big R squared is 6. This is 6 minus 4. So this is 16 over 49. So by the time we finish it and simplify, we should be able to have 2 over 7 root 437. So we have known our radius. So this is be the radius of the circle. So that is the radius of the circle. Now the question is, we want to find the coordinate of the center of this circle. Before we do that, we need to know this OM. We need to get this OM, this line OM. And if you want to do so, we use equation of a line. But before that, just try to know that this line passes through this center, which is this. It passes through this. Also, if it passes through this, we need the direction vector of the line. So since if you look at this line, you see that this line is perpendicular to this plane here. To this plane we are talking about is perpendicular to this plane. And if a plane is perpendicular to a line, we know that the normal vector of the plane will be parallel to the direction vector of the line. So in that case, the equation of OM will just be x minus, it passes through this, so that will be plus 2. It should be x minus the point that is there equal to y minus, this is plus 2 again, equal to z minus, but this one is 3 this time around. Now over what? From what we said the other time, if a line is perpendicular to a plane, definitely the normal vector of that plane will be parallel to the direction vector of the line. So in that case, they must have the same normal vector. So, and this is the normal vector of this plane, 2, 3, 2, 3, 4. So they have the same thing since they are parallel. So this will be 2, 3, 4. So that is a line. So from this, let's express it in terms of parametric equation. Let's assume that it is equal to t. So from this, if you make s the formula here, it will be 2t minus 2. If you make y the zero formula, this will be 3t minus 2, and z will be 4t plus 3. So that will be the parametric equation. So this line now, any line on this MP, this line MP, any line of this, any point of this MP must satisfy this, because this line is perpendicular to this. This line, this straight line here, must satisfy. Let me write it. Let me put it in word. As we have it here, any point on that line MP must satisfy s, y, z. Although we don't know, so we will now assume that this place now is our 2t s, y, s. Now we know that this plane is this 2s. It's also a plane on that. It's also a plane on this line. So in that case, we can write from the given plane 2s plus 3y plus 4z equal to 12. We can put these values there. This is 2 into 2t minus 2 plus 3 into 3t minus 2 plus 4 into 4t plus 3 is equal to 12. So from this, it is easy to find our t. Without stressing ourselves, t will be equal to 4 over 49. So since we have known the value of t, I can now put it here. We can now say that hence m will be equal to that point m. This point m here, it will be equal to, I'll put t, anywhere I see t, I'll put it as 49 over this. And without any more stress there, we should have 90 over 49 comma, minus 86 over 49, comma, 171 over 49. So that will be the coordinate of the center of the circle. Let's take another example involving this. We have another question here. We have to find the coordinate of center and radius of this circle. In order to get it right, you need to draw it so that you understand it better. So this is the plane here. This plane. This is the radius of the sphere. And let's say this is a line here, a line on this plane, and this is a perpendicular line. Let me call it this place M as usual. This is L, this is P. Now we need to find the radius and center of this sphere first, because they will help us. So we write it as follows: center of the sphere. So what will be the center? Half of this, negative of half of this. So this will be 2. Negative of half of this is minus 1, and there's no z there. That will just be 0. Definitely our radius will just be square root of this squared plus 1 squared plus 0 squared. There's nothing there again to put as squared. So finally our answer is just root 5, because there's no any constant there. It will have been minus that constant too, but there's no constant. So we have found the center and radius of the sphere. So from this place, it will be very easy for us now to now find our length OM, this place, which is the distance between this place and this place. And our answer will just be, we use this thing, absolute value of x plus z. That is, our x is 2 plus z. Our z is 0. You bring this 1 in, it will be minus 1 over square root of a squared plus b squared plus c squared. So our a is 1, our c is 1, but b is not there. B is the coefficient of y. So from this place, this is 1 over square root of 2. So we cannot find our radius of the circle. So this should be r squared minus l squared. This is root of, if you square this 5, it will be 5 minus, this is half. So finally there, we have 3 over root 2. Or if you rationalize it, you have 3 root 2 over 2. So that will be the radius. We have found the radius of the circle. So let us now move to the center of the circle. As I said in the last example, before we can find the center of the circle, we need to know the length of this line. We need to know it. So, and the equation of this OM. If you know it, it will help us out. So how do we now find the equation of the OM? You know, the OM passes through the center, this place. So there we have x minus 2 over, we are coming there, is equal to y plus 1 equal to 0 is not there, z minus 0, then over what? So the normal vector of this plane will be parallel to the direction vector of this line. So the direction vector of this line is just you can see y is not there. So for the x part is 1, this place is 0, and the z part is 1. So the coefficient, so this will be the line. So let's assume that let me say the line OM is this. If we make S a formula, S will be equal to t plus 2, y will be equal to minus 1, yz will be equal to t. So in that case, any point on line MP will be equal to this. How did we get this? This, and this. Which any line on any point on this line MP will be equal to this. And we know that on MP, we have x plus z is equal to 1. So let's substitute it there. This will be x. Our s is t plus 2 plus z. Our z is t is equal to 1. Without stressing ourselves, so you see that t is equal to minus 1 over 2. So if t is equal to minus 2, then the coordinate of the center of the circle, this is center. The coordinate of the center of the circle is, we put t to be minus 2. That is minus half, that is 3 over 2. Minus 1 remains. This is minus half. So this is the coordinate of center of the circle. Let's consider another example. Now we have another example here. Obtain the equations of a sphere through this circle, these two, and intersect the plane this in a circle of radius 3. The first thing is, let us obtain a sphere that passes through these two equations, and we know that that one will be s plus mp is equal to 0. This is a sphere, this is a plane. Now that will be this. As you can see, this is s plus mp. So we now need to simplify this. When we simplify, we get this. We have simplified it further. So this is the required equation of sphere that we are looking for. But now we need to know the value of this m. It will lead us to the remaining information here. Firstly, we need to find the radius and center of this circle. You know, center is very easy to get. This sphere now, center of 1. You know, the center of 1 will be minus half of this, that is minus, let me say, m plus 2 divided by 2, comma, the same thing, minus m plus 2 divided by 2, and then this one too, minus half of this, minus this. That will be the center. Now we now find the radius. You know, radius will now be square of this plus square of this plus square of this minus this constant. And that is what we have written out. So this will be the radius. So the next thing is, we just need to simplify further. So by the time we simplify further, we are going to get. So let's keep this. Let's keep it. We are coming to these two. But the sphere we are talking about, this sphere 1, intersects this plane. So we need to write it out, and we need to draw it for better understanding. As you can see, but sphere 1 intersects this plane, this given plane, in a circle of radius 3. Let's assume that this is sphere. This is sphere. So this is plane is intersecting. So this is center of the sphere. Let's say this is the radius, which you have found. This is center, which is O. Let's say this is M. Thank God we have now told in the question that this place is radius 3, the circle of radius 3. So this place has been told. Also, we can find the value of OM using, you know, OM is distance from this center to this plane, and this plane is this. So I will just use this formula here now to get our OM. Now, OM, this OM will just be this L. Let me put L there. So our OM will be L into, you know, what we have there is S plus Y, and this is our S, this is our Y. So this will be minus into M plus 2 over 2 minus M plus 2 over 2. Put absolute value there, over root of A square plus B square plus C square, but there's no C, it's just 1 plus 1 over this. So which at the end of the day, the absolute value will neglect the negative. So finally we are going to have M plus 2 there divided by root 2. That is our OM. So by Pythagoras theorem, we know that OM squared plus MP squared is equal to OP squared. That is by Pythagoras theorem. So we have known OM, which is our L. So if you square it, we should be able to have M plus 2 squared over 2 plus MP. MP is the radius, which is 3 plus 3 square equal to OP square. OP square is the radius. OP is radius of the sphere. So we need to square this so that that place will just become 3m squared minus m minus 8m plus 8 over 4. You know, it is in square root before. When you square it, the square root will go, this will be over 4. And that is what we have seen here. So this will just lead to quadratic equation, which we can do. At the end of the day, we finalize it from this place. We solve the quadratic equation and we get m is equal to minus 2 or m is equal to 18. So since we have known the value of our m, we can now substitute it in 1 in this place. We first substitute when m is 2, when m is minus 2, and when m is 18. We substitute separately so that we get this. So when m is minus 2, we put it in 1, we get this. When m is 18, if you put it in 1, we get all this. And these are our 1 here. If you put m to be 2, minus 2, and 18, you are going to get the required answer. Let's take another example. So we have another example here, but this will be left as exercise. Find the equation of a sphere whose extreme diameter are this, and find also the area of a circle in which this sphere is cut by this plane. We first use the formula for finding area of a sphere in which diameter are given. Also, we merge it with it to become a circle. Then we need to find the radius of the circle before we can find the area of the circle, which is pi r squared. So I will leave this as exercise for you. So this will be your exercise, and also you can take this too as a exercise too. A very important question. So our next topic will be equation of tangent plane to a sphere. Have a nice day.